Hello everyone, my name is Dave Feldman. I'm a professor of urban planning and public policy here at the University of California, Irvine, and I also direct Water UCI, a center engaged in research, education, and outreach. We've all been reading about climate change and its impacts on humanity and on the environment in recent years, and we know that it affects many things. But have you thought about how it affects water, and particularly here in California? How changes in climate can affect variations in the availability of water, droughts versus floods, for example. Today we're going to talk about that issue of climate change and water in California. I want to start out with a little bit of a global perspective, and then I want to focus on some issues that are much closer to home. I want to begin by suggesting that climate change and water is an international problem. It's already affected a number of places. Two, in fact, are India and South Africa, both developing countries that have experienced dramatic population growth, a growth in urbanization, and the impact of climate on water supply. When you combine all those things together, it's not surprising that big cities like Chennai, India, have been suffering from water shortages because people are consuming too much water and climate variability is affecting the rainfall and precipitation in the region. Likewise is true with South Africa, which just a couple of years ago came close to experiencing what they called Day Zero, literally the day that all of their local reservoirs would simply not have water to support the city. Fortunately, Day Zero never came because the city took emergency measures to hold themselves over until the rains returned. And while they're not totally out of the woods yet, they're doing better. Now, when you look at Chennai, India, and you look at Cape Town, South Africa, a question that might arise is, could something like this happen to us here in California? Well, that's one of the things that people who study climate and water are very concerned about. Let me start in talking about California with this particular slide, which comes out of a report that was produced by the United States government a couple of years ago, called the Global Change Research Program. Most of our water in California, and for that matter, most of our public water supply in the West, originates in the form of snowfall, which accumulates on the Rocky Mountains and on the Sierras. The more snowpack you have in the winter, the more snow melt you're going to have in the spring and summer to replenish our groundwater basins and our rivers and streams. That's good news for farmers. It's also good news for those of us living in cities. However, as you can see from this particular slide, over time, climate scientists believe that there will be less snowpack available in the various states of the United States West. And as that snowpack diminishes, snow melt will likewise diminish, which means eventually we'll get to a point where we will not have as ample a supply of water available to us as we do in the present. And this affects different states unequally, as you can see. California is not going to be in very good shape. We're going to be in a position where roughly we'll have maybe half the amount of water from snowpack that we have today by the end of this century. On the other hand, places like Arizona and New Mexico will have almost no water from snowmelt. So the question is, what are they going to do, and how will their choices affect us? Sea level rise and coastal flooding. We talk about drought, but we also need to talk about floods on the other extreme as being something that can affect California as a result of climate change. How many of you realize that since the 19th century, when we first began to measure sea level at our coastal areas, the sea level rise has already taken place? And in fact, several inches, as gauged at the infamous and beautiful Golden Gate area in California, is a really significant measure of how much sea level rise has already occurred. When you combine that with intense rainfalls, which will happen in some places in California, coastal flooding is something that we're going to be very vulnerable to. And that's going to affect populations living along the coast. which includes over half of California's population that lives within 25 miles or so of our coastal areas. We talk about weather extremes. This is Hoover Dam. If you've been to Las Vegas, you've probably visited the dam. And if you visited it in the last few years, you probably noticed that water levels behind the dam in what is called Lake Mead have fallen quite dramatically over time, leaving this notorious bathtub ring you see on the slide on the left. That bathtub ring is caused by the fact that inflow, again, snowmelt from the Rocky Mountains into the Colorado River, has declined over time. At the same time, our demands for water in all 7 states adjacent to the Colorado River, including California, have not abated. In fact, they've increased. And as a result of that, we're drawing down this reservoir to very dangerous levels. I want to make one more observation, and this has to do with the relationship between water and energy, what many experts refer to as the water-energy nexus. Hoover Dam is a great producer of power. This picture on the right shows you towers that are actually intake structures. They take water from behind the dam and run it through turbines to generate electricity. If the water level of Lake Mead falls another, say, 15 or 20 feet, entirely within the realm of possibility, given climate variability, this dam will no longer be able to generate electricity. That will have a dramatic effect not only on Las Vegas, but on those of us living in Southern California who depend upon this dam for peak electrical power. I mentioned climate variability, and that's a term I like to use more than climate change because it emphasizes the fact that as climate is altered, extremes will also be altered. We will have periods of protracted drought, but they will be punctuated by periods of intense rainfall. 3 years ago, we experienced that exact phenomenon up in Northern California at Oroville Dam on the Feather River. You might remember this dam actually almost collapsed. It was in great danger of causing tremendous floods downstream because a spillway structure, as you could see in these pictures, virtually failed. This dam is still being repaired as we speak, and the cost is upwards of $100 million. So while infrastructure can alleviate some of the pressures of climate change, even infrastructure cannot alleviate all of them. And as climate becomes greatly altered as a result of the changes that we're imposing on the environment, our water systems will also be altered severely, and we may see more near disasters like Oroville. So what can we do about all this? Should we just throw up our hands and assume that climate change is inevitable and there's not much we can do to change the trajectory? Well, while countries debate and clamor over plans to perhaps negotiate viable treaties involving the United States as well as other countries in lessening emissions of greenhouse gases, in the meantime, there are actions we can take to fortify or make more resilient our water supply in light of climate changes that have already occurred and that will continue to occur over time. Droughts are natural, and that's a principle that we need to begin with. What climate change does is make these droughts more frequent and more intense. And our behavior, our avid and prolific desire for more and more water can worsen the effects of these droughts. Resilience is what we need to aim for. And by resilience, I mean a transition to renewable, low-energy sources of water and more reliance on what we call integrated management, where we not only seek new sources of supply, but we seek to lessen or lower our demands for water. In other words, to conserve. How can we do that? Well, we can avoid waste and conserve. We can also become more efficient in the way we use water. We can reuse every drop of water. Here in Orange County, where I'm speaking to you today, we recycle most of our wastewater and use it as drinking water. It actually serves to replenish the groundwater basin, which is directly under the building from which I'm speaking to you this afternoon. We can also harvest new sources of water. Stormwater harvesting. When it does rain in California, which isn't very often in recent years, we can capture that rain. We can store it. We can even repump it into our groundwater basins. And yes, some options like desalination may be appropriate in certain places and in certain applications. We need to be creative, imaginative, and we need to be inviting of all viable options within our region. So what makes an option resilient? People often ask, what's the right option to choose to fortify ourselves against drought and flooding? And what are wrong options to use? Well, one of the things that I'd like you to take away from this presentation this afternoon is that what makes an option resilient is not one thing, but many things. First, we want to make sure that any option we choose is technically feasible. Do the science and engineering support its application? We want to be novel, but we don't want to be so novel that we come up with technologies that are not really going to work to serve the water needs of some 40 million Californians. Secondly, how expensive is our option going to be? As it turns out, most alternatives to fortify California's water supply are probably going to end up costing consumers more, and it's probably going to be reflected in our water bills. Is that a suitable price to pay for a resilient water supply? Well, only you can decide that, but we know that desalination and wastewater reuse are fairly expensive options, at least initially. On the other hand, the more important question to ask is not how costly is an option, but how expensive is it relative to other alternatives? And who pays for these options? Can we develop pricing systems that are equitable? And as we'll see in a few moments, that do not unduly burden those who already are making great effort at conserving water, but charge more for those who use more. Every option has an environmental impact and a risk of some sort. The question isn't, can we come up with an alternative that poses no impact on the environment? Just think of how a desalination plant would look along a coastline and whether or not you can mask its appearance to make it blend into a coastline. That's an aesthetic concern that is increasingly being voiced in California and elsewhere around the world where desalination is being introduced. The question isn't, can we eliminate environmental impacts and risks? The question is, can we mitigate or lessen these impacts to make them basically more acceptable to you and I? This is a huge challenge, and students of urban planning, for example, are studying these issues all the time and have introduced a number of ideas for how we can make sure that stormwater harvesting and wastewater reuse and desalination and other options can suitably and appropriately blend into our built environment so that they fit and do not lead to dissatisfaction among people. And last but not least, public acceptability and public engagement. Every alternative has risks, has costs, and has questions regarding technical feasibility. But most of all, in my view, as a student of water resources policy for much of my career, I believe the most critical issue is whether or not the public believes that it has a voice in the implementation of these options and that it perceives these options and the way in which they're managed as trustworthy and the people who manage them as being competent and worthy of having trust reposed in them. If we can meet these four criteria, we've probably found a good, resilient option. Finally, in making options resilient and most of all acceptable, it's very important that we have political leadership at the forefront of our efforts to become more resilient and to fortify ourselves against the impacts of climate change on water. This particular picture shows you former Governor Jerry Brown signing a state declaration declaring us in a state of emergency as a result of our last drought. This was not only a difficult act, but in some ways a politically courageous one. The governor was asking all of us, you and I, not just water agencies, to make sacrifices, to think about every drop of water we use, how to conserve it, how to use water more wisely, and how, whether we were farmers or people living in cities here in California, we could work together, pull together to get ourselves out of this emergency. Leadership is extremely important. And we know that when Governor Brown declared this emergency and asked water agencies to reduce their water provision to you and I by an average of 25% statewide, people in California courageously, like their governor, rose to the forefront and did a good thing. They saved, they conserved. And here's some evidence. Water demands during our drought, both along the coasts of California and inland, where there's a lot of agricultural activity and also a lot of demands for water because of higher average temperatures. Water demands did decline during the drought. It proves that we can do it. We don't have to look at water use as being something for which there are no limits to our consumption and something for which we cannot lessen our demands when we need to do so. There are some international lessons that might be worth embracing. Colleagues of mine and I have spent a lot of time in Australia, which is facing very comparable challenges to those in California. Australia recently went through something called the Millennium Drought. Called that because climate scientists believe this was the most severe drought that Australia had experienced in probably 1,000 years. As a result, they employed public engagement to get people to think about ways of conserving and reusing water. And as this slide indicates, that included voluntarily installing rainwater tanks to capture whatever rainfall would fall in people's communities so that it could be recycled and reused in toilets, washing machines, and even sinks for washing dishes. And in addition, the recycling of wastewater or effluent, as also shown in this slide, which grew exponentially during this Millennium Drought as Australians voluntarily worked together to figure out ways of reusing wastewater in ways that they might not optimally do in normal times, but at least was sufficient in abnormal times. I mentioned conservation a few moments ago and the fact that we can conserve when we want to. Well, what about when we're not in a period of drought? What can we do better? And one answer to that question is something that's already being practiced throughout California, particularly right here in Irvine, where I'm speaking to you. What we call an allocation-based rate structure, a system in which water rates are charged depending on how much water you use. The more water you use, the higher a rate you pay per gallon of water. The idea here is to encourage people to become more aware of how much water they're actually using, especially in terms of outdoor uses, which is a huge water demand in Southern California. That's why, as I mentioned here, that allocation-based rate structures use a property-specific water budget. That is to say, depending on how much irrigable landscape you have on your property. We can also use something called a water smart billing system, showing residents how much water they're using compared to their neighbors, and also comparing to the most efficient households in their a particular block or subdivision. We call this phenomenon norming. People like to be in line with what their neighbors are doing. And if they find out that they're using more water, probably their first reaction is they have a leak somewhere, which may in fact be the case. Your local water agency would be glad to come out and decide if that's actually the case. But it also makes us more aware of ways we can cut down our water consumption. We can also provide rebates, as many water agencies in California have done, for converting our lawns to drought-tolerant landscaping. The city of Las Vegas has reduced water use outdoors by some 75% in recent years, as well as by mandating very high-efficiency landscaping. Finally, it's good to know that there are things that don't work very well. During our most recent drought in California, a number of people took it upon themselves, as this young man did, to take his smartphone and photograph people who were violating rules against watering your lawn during certain times of the day. This process of shaming or outing doesn't work. It may have a cathartic effect. It may make you feel good because you've basically exposed someone who's violating a social norm, but it doesn't work, and in fact, it can backfire. It's better if we work together as a community than if we criticize one another for doing or not doing certain things. So I want to conclude this afternoon by noting a couple of things that I think are very important to bear in mind as we move forward in facing these challenges. First, we need to get realistic about what climate challenges are and the fact that they're really not new. Those of us living in the western United States, and in particular California, have to some degree always been deniers of the impact of climate. In the 19th century, the federal government used to encourage pioneers to move westward by saying that rain will follow the plow. If you settle the earth and you till it, the rains will follow. Now we know that that is not true and that that was not a very scientific proposition, but it was something that people believed. In addition, don't blame population growth alone for water demands. In fact, it turns out that profligate consumption isn't caused by how many of us use water, but by how the many of us use water. Large-scale, publicly subsidized water projects, which are found throughout the West, and in particular here in California, have historically induced our profligate use of water. Now that we can no longer build large dams, now that we can no longer divert water from great distances, as we did at the turn of the 20th century from Owens Valley to Los Angeles, for example, we need to be smarter. And we need to think about ways that we can support the same number of people with less water and using the water more wisely. And finally, there are no panaceas. We do need large-scale infrastructure. We also need adaptive options that are flexible and that generate fewer adverse impacts and that help ensure that we will have a resilient future. So let me sum up by saying the choice is ours. The future really is in our hands, and there are things we can do to make ourselves resilient against the impacts of climate change on water. Thank you very much for your attention.